Hi, and welcome to the Digital Job Site, where the boards are straight, the weather's great, and there really is a board stretcher. This video is the third of three parts of my Model and Measure series, and is titled Demystifying Hip Roofs by Measuring in SketchUp. And for those of you that are following along, part one was demystifying hip roofs by visualizing in SketchUp, and in that video kind of showed the how and why of the way that various components that make up a hip roof are cut and assembled to create flat roof planes that intersect in straight lines on the hip rafters. And then part two was demystifying hip roofs by modeling in SketchUp, where I showed how to model the various components and rafters that make up a model like this hip roof. And I did it in a 7/12 pitch just for a standard reference, but all the information in this series is intended to be structured so you can use it for any pitch that you might encounter framing a roof. So with that for background, this third video talks about how to measure, demystify hip roofs by measuring in SketchUp. And to do that, we'll just go into these various rafter components and show a couple of tricks for measuring and getting the information you would need to lay out and cut hip roofs. So I'm going to shut off a layer here that we call decorations to keep the model moving along. And if you'll remember, this plywood sheathing on a roof bears on the edges of the hip rafter and the faces of the common and jack rafters. And to achieve that, we had to drop the hip rafter. So I'm going to take away this other bit of roof sheathing and then hide the common rafters, just to take a few things out of this model. And then we'll minimize that layers box. And this shows basically the hip roof package. And one of the things about this model and measure method is that there isn't any information here that can't be that you can't come up with using a construction calculator or rafter tables. That's how it was done since the Egyptians probably. But the thing that I like about this method is how visual it makes all the results. And what I'm talking about is when you use a construction calculator and you enter the information for a common rafter length, for instance, you're going to start out with the overall span, which in this case is 20 feet, and divide it into, which would be 10 feet, and then subtract half the thickness of a ridge, which in this case is 1.5 inches thick, so so you have to take off 3/4 of an inch from 10 feet, which gives you 9 feet 11 1/4, if I'm thinking straight. And when you do that, and what I'm doing here, I'm just taking the line tool, and I started at this point of this common rafter, which would indicate the run of it, the run of that rafter. And my line's going down in the blue direction. And I want to hold down the shift key and then go to this top plate. Actually, I'm going to back up a step. And if you'll remember from one of the other videos, I had something called a heel height plane. So I'm going to turn that back on. Now we'll go back in, take the line tool, click this intersection point of that rafter. Once my line's going in the blue direction, hold down the shift key and then just hover over this heel height plane, and it stops that line vertically at that level. And now I can just draw horizontally in the green direction and get a horizontal line, and that represents the rise and run of this common rafter. And once I click back up here to this first line, you can see that it flashes into a plane. So we've created triangle that represents the rise and run of a common rafter with a 7/12 pitch and a 9 foot 11 1/4 inch run. So when you enter the dimensions into a construction calculator, if you enter 9 foot 11 1/4 inch run, 7-inch pitch, and then calculate the hypotenuse, you'll get this line here, and it'll give you a dimension of 11 foot 6 1/16 if I use my calculator correctly. But I've selected the line, then I'll right click and choose Entity Info, and here we come up with the result of a calculation from a calculator. Like I said, if you enter the 9 foot 11 1/4 run and the 7-inch pitch, which gives the calculator this angle, it'll give you a rafter dimension of 11 foot 6 1/16. And what that is the length of the rafter on a diagonal to get from the face of the ridge to the outside of the wall sheeting. Is in this case is the dimension that I used for the run of the rafter. So that's all pretty simple to go. It's obviously faster to click a few keys on a calculator to come up with that specific line for a common rafter. Where this tends to be more of a benefit, this model and measure idea, is to when it comes to the hip rafter itself and jack rafters. And what I mean by that is, if you put these dimensions, the 9 foot 11 1/4, 7-inch pitch, into your calculator, it'll come up with a length for the common rafter. And then if you hit a hip valley key, it'll give you a dimension of 15 foot 2 and 27/64 for the hip rafter. What I'm going to show is what that measurement is. It's using the same rise and the same run as the common rafter, which is that distance there, and that's the length it's going to come up with. I'm just going to click these two lines, and now we have another plane which represents the math that you would get from using a construction calculator when you put in the 9 foot 11 1/4 inch run and a 7-inch pitch, and then get a hit a hip valley key. You'll end up with this line right here, which, like I said, is 15 feet 2 and 27/64. But when you look closely, the dimension it's giving you is to a point that is not actually on the rafter you're going to cut, because the hip rafter is dropped. So it's giving you a length that doesn't represent something you can easily measure. You can transfer this number and deduct for these differences, but my thought is that it's much easier to draw this model and then simply click these 2 points. And this, if you're laying out a hip rafter, I'm going to zoom out here and take a look at the hip rafter that I put on the sawhorse, which I hid in the decorations layer. When this rafter is laid out, every carpenter is going to do this a little bit differently, but when I'm laying out a hip rafter to cut, I like to put these 2 bevels at the top. I lay a framing square with 16.97 and 7 inches on the 2 blades of the square, come up with this angle, and cut these 2 45s. Then what I like to do is measure from this point, just measure down to where the bird's mouth is going to be. And that's not the measurement you get when you use a construction calculator. You get this other measurement represented by the blue line. So in this case, I can just click this point here and then click again down here, and I get the length by clicking that line. 15 foot 13/16 of an inch is the length I need to lay out on the rafter. And I can go into the details of this. The bird's mouth is notched out bigger so it clears the sheeting. Kind of talked about that in the other video. So I know that at this point the heel height is that 6 1/16 of an inch. But I'm not really going to cut that. I'm going to cut a little farther out. So with the model and measure, now that I've drawn this thing, I can just erase this line, draw another line in from where my bird's mouth is going to be up to the top. And I know that that line, by clicking it and looking at the entity info box, I've got 15 feet 13/16 of an inch. And I got it from the wrong point because that's the same measurement. So I'm going to delete that line and do it again. From this point where the bird's mouth is actually going to be cut to clear the sheathing. So we come up with another dimension. This line then is 15 foot 13/16. There's something that this program is frustrating me with. I need to get there. Yeah, it's stuck on that point. Wondering if there's a little software issue, if it's just operator error. Yeah, there is some reason the program has got that other dimension stuck in its head. I'm going to try to draw it from the top down this time and see. It's dividing it up into two separate lines. So the total, by adding them together, is this amount. Because I've selected both lines, it gives me the total length. And then the other thing about that is that the heel height at this point is no longer 6 1/16 because it's dropped down. So then I know that my heel height is 5 3/4. Another way I can get that is to just go parallel to the edge and undo that and get my dimension for a mount that's parallel to the edge and get two lines intersect. So that's 5 5/16 that way. So I hope what I'm conveying here, rather clumsily I guess, is that all these measurements, you can get the exact measurement you want and not necessarily just the one that comes as a result of the calculator, which you have to adapt. In this case, you can see exactly what you're laying out, what you're measuring, and use that information as you're laying your rafters out. I'm going to hide this decorations layer again. Actually, I'll leave it there for a second. And what I had done previously was taken each of the jack rafters from the model and I flipped them around and grouped them and put them here on the sawhorses. But this is what the complete set of jacks would look like, all stacked up as in the way they're cutting. And it might be simpler. Somebody might want to actually do this, create a pile of rafters like this for the actual measuring process. But for the sake of this video, the purposes of the video, I'm just going to measure them in place and show you a couple things there. So we can get rid of some of these guidelines that we were using. The information that's important on the jack rafters is the length of the jack rafter. Here again from the run, the face of the sheathing to this heel height plane. From this point, each jack rafter would be measured from there. And you can do a number of things. You can measure each one just by clicking 2 points, selecting that entity info, and it gives you the length of each rafter. You can do it that way, which is simple enough. If you wanted to take these dimensions, take them with the measurements on the rafters, you can just click like this and it'll put a dimension on there. You can measure each one this way. And sometimes it's difficult to get SketchUp to measure parallel to the edge. It tries to jump around and do funny things, but you can swing these things around and get get layout dimensions there. Again, if a person would take a pile of them on a set of sawhorses, it would be easy to dimension them, get all the dimensions going the same way. And let's see, I'll get rid of those two. Another thing that I remember from the old Rafter book days was on the face of a framing square, it gives you the length, the difference in length of those jack rafters. So from the common rafter, you'd step down a given dimension. That's very easy to determine here. If we just draw a line in the perpendicular direction, that is in the red direction in this case, and then measure this side of that triangle, it gives you 1 foot 6 and 33/64 is the difference in length of each jack rafter. Here again, this piece of the line. Oops, that way we got a whole group in there. If I click this piece of the line, this piece right here, and that doesn't, that line doesn't represent the difference, but it's here. Went to the wrong edge of that rafter. So this is the 1 foot 6, and it is being particular there. I guess the point there is that each jack rafter is different in length from the one next to it at 16 inches on center, and they're all, that increment is the same each time. As you can see there, and that was a little clumsy, but that's basically the process. You can use either of those methods to calculate the difference in the length of those rafters. But I hope that the video shows enough of the process and how the measurements, how you can obtain them from a modeled drawing. And one of the things that I think I explained in the previous videos is that this is an even pitch. It's 7/12, very even number. The span, I made it 20 feet, you know, so all the figures here are nice round numbers. But when you start changing things, if you've got a 9 1/4 12 pitch, or if you've got a 17 foot 2 1/2 inch run, any of those things, as you start to change those, it gets more it gets trickier, more complex to do these things with a rafter table or a construction calculator. And even then, you need to understand what the calculator's dimensions are giving you, what they represent on the actual rafters themselves. So I like the model and measure method, and I'll put in the blog at finehomebuilding.com on the Digital Jobsite Blog. If viewers are interested in the benefits of using this method for doing off-angle hip roof framing, where the slopes of the two intersecting roofs aren't at the same pitch. In this case, they're 7/12 on both sides, but if you had a 9 1/2 12 on one side and a 6 on the other, it throws all these angles become non-standard, and the centering of the hip rafter changes, the overhangs change, there's variables there, and when you start throwing those complexities into the framing, the model and measure method really starts to excel in providing the results you need for rafter layout. Anyways, I'll stop this there. Thanks for watching. I hope that you'll comment or visit at the Digital Job site. If there's things that I've left out of this, I'd be happy to try to address them in a future post. In the meantime, thanks for stopping by the Digital Job site.